We've talked a little bit about significance testing. We said, really the first step in a significance test is to start with your hypothesis. You have your null hypothesis, which is your original claim, and then you have your alternative hypothesis, which is whatever it is that you're trying to prove. Now, after you state your null and alternative hypothesis, you go through and start collecting evidence in order to make a decision about these hypotheses that you set forth. Now, that's the part we're going to talk about now, is we're going to talk about the evidence and making decisions. And I'm going to correlate this to the justice system. So in America, our justice system, we say innocent until proven guilty. Well, by that standard, your null hypothesis would be that the defendant is innocent and the burden of proof is on the prosecution. They have to prove that the person is guilty. If they don't have enough proof to show that they're guilty, then they will go free. But if they do have enough proof to show that they're guilty, then they will be put in jail, or whatever the circumstances are. So at the end of the trial, the prosecution gets up, they deliver the evidence, the defense has a chance to kind of combat that a little bit, but at the end of the trial, the jury stands up and there's only two things that they can say. They either say guilty or not guilty. Now, what does that actually mean? Guilty means that you reject the null hypothesis. You're going into this thing assuming that the person is innocent. So if you come out at the other end and the jury says guilty, that means they have enough evidence to prove that they are guilty. We're going to reject that they're innocent and we're going to conclude that they're guilty. All right? The other option, the jury stands up and sometimes they say not guilty. Now be careful with what that one means. Not guilty doesn't necessarily mean that the person is innocent. Not guilty just means that you fail to reject the null hypothesis. It basically means there wasn't enough evidence to prove that the person was guilty. Okay. Now I want to put this in perspective for you. I'm going to take you through a very prominent court case. We're going to talk about the O.J. Simpson trial. Now there's a lot of TV documentaries that have come out in the last several years about the O.J. Simpson trial, and they're really, really fascinating to watch. You can absolutely watch that to get some more information. I'm really just going to be talking about the prosecution side in their attempt to prove that O.J. was guilty. So here we have some of the data that was collected, some of the evidence that was put forth. So O.J. was married to Nicole Brown Simpson. They had a very tumultuous relationship. There were actually several incidents of domestic violence during their relationship, and eventually they were divorced. Well, in 1994, Nicole Brown and Ronald Goldman were stabbed to death at her condo. And, the police, once they show up there and they find, blood all over the place, and they think, okay, we need to go check on O.J. He was married to Nicole, so they go to his house and they find some blood on his Bronco. They find some blood on the doorsteps, and so they're kind of in a panic until they find a glove in his backyard that is covered in blood, and there was a similar glove found at the crime scene that they start thinking, oh, okay, maybe he did it. And so they call him up. He's not home. They call him up. He's out of town now. And they tell him, O.J., Nicole Brown, she's dead. She's gone. And the interesting thing of this conversation is that he seemed upset, but he never asked what happened. I mean, she's a young woman. He didn't ever ask how she died. So that was kind of a first, very suspicious way for him to react to that. Anyway, they go on and they go through some DNA testing. They bring him in. They finally get him in for questioning. And turns out that O.J.'s blood was found at the crime scene, and he did have fresh wounds on his hand. For me, the big thing here is that Nicole and Ron's blood, their blood was found in his Bronco, on a pair of socks in his bedroom at his house, in his driveway, and in other places in his house. The gloves, they did match. There was one at the crime scene and one that was found in his backyard. There were bloody footprints of a size 12 Bruno Magli shoe found at the crime scene. This was a very rare pair of Italian shoes. What I read was that there were only 29 sold in the United States, and in pictures of him before all of this had happened, some of the shoes appeared like they might have been that brand of shoe, and you can see he wore size 12, so they did a little shoe impression of what that would have looked like. Notably, he did flee from the police. He was supposed to turn himself in, and then he, ended up on a national television at a slow speed car chase. And then after all of this was said and done and he was acquitted, I'm sure several of you have heard the saying, if the glove doesn't fit, you must acquit. So at the end of all this, despite all the evidence, he had a wonderful defense team and he was acquitted of these 2 murders. Later on, he wrote a book, If I Did It, Here's How It Happened, where he basically goes through and explains what happened that night, what led up to this event, and so on and so forth. So, as you can see here, there is just a vast amount of evidence that was presented to the jury. And really, when it comes down to it, the jury had to think about this statistically. They had to think about the probability. Like, what's the probability that all of these events would line up if he is really innocent? Right? So our justice system, we said innocent until proven guilty. So as this evidence is rolling in from the prosecution, the jury is weighing the probability. What's the probability of obtaining this evidence if the defendant is innocent? So in OJ's case, if OJ was innocent, what's the probability of finding the victim's blood in his Bronco? If OJ was innocent, what's the probability of finding the victim's blood in his driveway, in his home, on his clothing? If OJ was innocent, what's the probability of finding a glove that OJ was known to own at the crime scene covered in blood, in the other one in his backyard? If OJ was innocent, what's the probability of him writing a book about how he did it? All in all, the probability is low. You wouldn't expect those things to happen if he was innocent. That's what makes us think that he's guilty. So here's our catchphrase. When the probability is low, reject the hoe. When the probability is so unlikely to happen if that null hypothesis is true, you have to reject the null hypothesis. So when P is low, when the probability is low, reject the hoe. Okay, so when I say p-value, I'm talking about probability. The p-value tells you how likely a result is to occur if the null hypothesis is true. And again, when p is low, reject the hoe. Let's shift our thoughts to something slightly less morose here. We're going to talk about a pizza delivery service. This pizza delivery service boasts an average delivery time of 30 minutes. Assumed delivery times are normally distributed with a standard deviation of 5 minutes. The manager of one branch is concerned that deliveries are taking a little bit too long. Okay, so your null hypothesis here, you're going to assume that everything's hunky-dory. You're assuming that the mean is really 30 minutes, but the manager is suspicious that it might be taking a little bit longer than that. So our null hypothesis is that the mean is 30, and our alternative hypothesis is that the mean is greater than 30. All right, so what does he need to do? The manager thinks things might be taking too long, so he needs to collect some data. So he selects one delivery at random, and he finds that that one delivery took 33 minutes. Now, obviously, 33 minutes is longer than 30 minutes, but what we need to do is weigh the probability. Is that just a coincidence that that one delivery took longer than it was supposed to, or is this enough evidence to think that they're all taking too long? That's what we need to figure out. So we're going to have to calculate the probability here. What's the probability that one delivery takes 33 minutes if the mean delivery time is really 30 minutes like it's supposed to be? So it said normally distributed up here, so I'm going to draw a normal curve. And this thing is supposed to be centered at 30, right? That's our null hypothesis, is that this thing actually takes 30 minutes. But this one sample wasn't 30 minutes, was it? The one sample was up here at 33. So I want to calculate what's the probability of that. Okay, so in order to do this, we're going to do a z-score, right? So I'm going to take my observed value here. I observed that this delivery took 33 minutes minus my expected value. I expected it was supposed to take 30 minutes, divided by the standard deviation, divided by 5. So calculate my z-score here. 33 minus 30 divided by 5 is 0.6. Now that's my z-score. Now I need to go look up my probability. So I go to my chart. I'm looking up a z-score of 0.6. 0.6 gives me a probability of 0.7258. 0.7258. Now remember, when you use your chart, it's giving you the probability from here down, but we want the probability from here up. So I'm going to have to do 1 minus 0.7258, which is a probability of 0.2742. Now, that's my p-value, that's my probability. What does that even mean? So here my probability is 0.2742. And remember, the p-value is the probability of getting this evidence if the null hypothesis is true. So focus on this part right here. If the delivery time is really 30 minutes like it's supposed to be, then we would expect a delivery of 33 minutes or more in about 27% of all possible samples. So 27%. It's a low number. It's unlikely, but it is far from unusual. If something happens 27% of the time, it's not all that unusual. So go on to read here. This result is not that unusual. So there is no reason for us to believe that deliveries at this branch are taking longer than 30 minutes on average. Okay, right, if something happens 27% of the time, that's not strong enough evidence, that's not unusual enough for us to think the null hypothesis is wrong. So let's do a little bit better job of the statistics here. One delivery at random is not really going to tell us a whole lot. Let's up our sample size. So here we have the same situation. The pizza delivery service is supposed to take 30 minutes on average. Standard deviation is still 5 minutes. And again, the manager is concerned that deliveries are taking too long. So our null and alternative hypothesis here is the exact same as we saw before. We're assuming that the delivery time is 30 minutes, but we think that maybe it's taking a little bit longer than that. This time, though, we are looking at 25 deliveries. And we find that the average delivery time for those 25 is 33 minutes. Now again, 33 minutes is longer than 30 minutes, but is that just a coincidence? Or is that enough evidence for us to reject the null hypothesis and conclude that the delivery time is really longer than 30 minutes on average? So we need to calculate the probability in order to make that decision. We need to know what's the probability of this happening. So I'm going to draw my curve here, right? It's normally distributed. I'm going to draw my curve. The mean is supposed to be 30, so I'm going to put 30 in the middle. But this sample wasn't 30. This sample was 33. So I want to know what is the probability of that. So again, I'm going to calculate my z-score. I observed that my sample took 33 minutes when I expected it to only take 30 minutes. Divided by the standard deviation. Just remember that here, because we have a sample size of 25, my standard deviation, or in this case standard error, is going to be 5 divided by the square root of 25. So when I calculate this thing out, I get a z-score of 3. Now, the z-score is not my probability. The z-score just tells me what I need to go look up on my chart. So I'm going to go look up 3. A z-score of 3 shows me a probability, 3.0, of 0.9987. Now remember, that probability is from here down, but I wanted to try to prove that the deliveries were taking longer than 30 minutes. So I need from here up. So I'm going to do 1 minus 0.9987, which is 0.0013. That probability, if you had to round that to 1 decimal place, that's 0. If you had to round it to 2 decimal places, that's 0. This is a very, very low probability. So here, our p-value is 0.0013. Now, remember what the p-value represents. It's the probability of getting these results, the probability of getting this evidence if the null hypothesis is true. So notice in bold here, all caps, here's my null hypothesis. So what that 0.0013 really means, the probability that 25 deliveries take an average of 33 minutes, if the delivery time is really 30 minutes like it's supposed to be, is only 0.0013. So there's basically a 0% chance of this happening if the delivery time is really 30 minutes like it's supposed to be. But it did happen. This is extremely unusual. So in this case, there is reason to believe that the delivery time is taking longer than 30 minutes. There's basically a 0% chance of getting these results if the null hypothesis is true. When the probability is that low, you reject the hoe. You reject that the delivery time is actually 30 minutes and conclude that it must be longer than 30 minutes. Okay, I'll say that one more time because I know this is really the big idea you want to wrap your mind around. The probability of getting 25 deliveries that take an average of 33 minutes is 0.0013. There is a 0% chance of this happening. So the fact that it did means the mean delivery time can't really be 30 minutes. It must be longer. All right, now we say when P is low, reject the hoe. Well, how low is too low? So that's where the significance comes in. Significance level is denoted as alpha. This is the level at which a p-value is considered extreme enough to be statistically significant. For us, we typically use a significance level of 0.05. Now, 0.05, that's 5%. So if something happens less than 5% of the time, you're saying, whoa, 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 that's too unusual to just be a coincidence. We need to reject the null hypothesis and conclude the alternative. But if something happens more often than 5% of the time, you're like, that's just a coincidence. There's no reason to reject the null hypothesis. So when P is low, you reject the hoe, and you say that you have enough evidence to conclude the alternative. Kind of like a court case, if you have enough evidence, you're going to reject them being innocent and conclude that they are guilty. All right? When your p-value, when your probability is greater than your significance level, you fail to reject the null hypothesis. In this case, all that means is that you do not have enough evidence to conclude the alternative. As far as a court case goes, if you don't have enough evidence, that's when you say not guilty. And all that means is that you don't have enough evidence to prove that the person was actually guilty.